Hi, everybody. So I've been thinking a lot about class on Wednesday, and I'm really not happy with how I explain Project 4. Project 4 is a really important project. It's basically starting over from scratch, and what happened in class I consider to be a real debacle. So while everything appeared to work okay in my environment, it broke for many of you, and that really threw me off my game. Um, I felt really I felt that I really rushed the content, and I, I was worried about making sure everything fit so we'd have enough time for pair programming. So what I wanted to do today is take some time here on a nice Saturday afternoon to walk through more completely and at a hopefully slower pace uh, Project 4, and so that we can all come back together next week with a much better idea of what it's all about. There'll probably be a couple of things that I'll repeat in next week, but I want to make sure that I've got something that is coherent and that everybody can access. Because pretty soon it'll be time for Project 5. Okay, so first I'm going to check to make sure the recording worked okay. Okay, recording looks pretty good. So now let's talk about the project again. So Project 4 is the next evolution of the phone bill application. And here we go from a single command line program that does things like manipulates files and formats dates nicely to a client server application that communicates using REST over HTTP. So there's a whole lecture that explains about Java web applications and the various APIs and what REST is all about. And I'm not going to duplicate too much of that here, but what I want to do is I want to set Project 4 in context and talking about all the pieces parts. So I think where I'm going to start, though, I already went through a bunch of this in class, but I want to start with a picture. So I drew a picture. I'm going to put it in full screen here so that we can. So and I'm going to talk to this picture, and I'm pretty sure the mouse is then captured in the on the video. So one of the things that makes Project 4 very different is that instead of two programs, there are multiple programs involved, multiple processes involved, and potentially even more than one machine. I think in all the examples that I'm going to show you, and in all of the testing and stuff I'm going to do, it all happens on one machine. But conceivably, it could be multiple machines. So here I have a diagram that hopefully depicts all of the pieces, parts, and how they interact. So on the right, we have the server machine. This is the thing that serves up the web content. And on the left, we have a client machine with various clients that we're all going to see. But I want to start over here on the right. Now, ultimately, in terms of the code, there's something called a servlet, which ends up responding to HTTP requests. But let me take a step back. So uh, here on the server machine, a Java web application runs. Now, a Java web application is a well, it is an application that consists of Java code, so class files, and then potentially other webby things that are served up, whether it's images or whether it's HTML pages. The whole idea is that a web application responds to web requests. It responds to URLs, right? HTTP. In HTTP, you have a URL and you have a verb associated with it, and you have a request. And in that request, there might be information in the header that then the web application consumes to do its work. Now, uh, and the web application runs on some machine. So here we're going to call it host one. This is going to be the server machine, the machine that runs the web application. All Java web applications run inside a Java virtual machine and are hosted in something called a Java web container. And a web container is a piece of software that implements all of the guts, all the internals of of a web application, mainly the stuff that's common across all web applications. So things that will listen on a port for a request to come in, does all the work with HTTP to read and parse the request, make some sense out of it, and then ultimately what it'll do is it'll look for a web application running inside that web container, deliver the request to the web application, and then the web application takes over and handles that accordingly. All this bottoms out into what's called a servlet. A servlet is there's an API, there's a standard Java API that provides objects that handle HTTP requests and return or populate HTTP responses, which are then sent back to the client. And so then a big part of your project 4 will be implementing this phone bill servlet, the servlet that implements the REST API. And so the REST API is spelled out in the assignment. And that's what our phone bill servlet does, right? So when the servlet receives, well, or rather, when the client issues a URL / phone bill / calls customer equals name, then there's this behavior, then there's this functionality. So when this URL is requested with the get verb, then it returns all of the calls using the text dumper. When it receives a post, then it creates a new phone call from the HTTP parameters. And so HTTP request parameters are sent in with requests, and later on we'll see how all of that is done in either an HTML form or in a Java request. So that's what the phone bill servlet does. It implements the vast majority of the business logic, sort of the back-end business logic, that handles the HTTP request, the REST API, and then returns some answer. So that's all the stuff happening here on the right side of the diagram. And the way you run the web container. Let me get my environment set up. Okay. The way you run the web container, and the name of the web container that we are using in this course is called Jetty. Jetty is an open source project that provides a web container that conforms to the Java Servlet API and all the other APIs for web containers, for web applications. And the way you run it is that you use Maven, and this is from the phone bill web project. You say Maven Jetty run. And what that will do is it will build the web application from source code inside the project, inside the Maven project, and it will start up a instance of Jetty, so it downloads all the stuff that Jetty needs, starts it up, and then it deploys the web application from the project into that Jetty. The Jetty is configured to run on port 8080 by default, and so now it sees that Jetty is running. So we can interact with this in several ways. I'll go back to the client machine, or the diagram here. So there are several kinds of clients that I want to talk about. The first one is a web browser client, right? We're running a web application. Browsers interact with web servers. And so then what I'm going to do is I'm going to browse to, I can click on that. That's neat. When I browse to, host 1 is not really a thing. What I'm going to do is create a new tab here. Let's close out some of these. So much. There we go. I'm going to browse to the following URL. HTTP, so that's the protocol. And then I'm going to say, then I'm going to say localhost. Oh, look, 8080 phone bill. So this is saying, hey, the host machine is the local host, which means the machine that I'm running on. It's going to be port 8080, and the application I want is phone bill. So when I run that, the web application responds with an index.html. So the web application here, let's just find that index.html. Actually, I got it right here. inside the Maven project, there's source main web app, which contains a directory called webinf, which has something called webxml, which basically configures your application. You can learn all about that inside in the lecture notes. I don't think it's really necessary to actually no, it's not necessary to change that for the assignment. There's also an index.html, and so this is a very simple HTML file that allows you to provides 1996 style HTML forms that allow you to interact with the application. And so what an HTML form does is it makes a call back to the server to a particular URL. In this case, there are 1, 2, 3 forms on the page. The first one lists all dictionary entries and has a submit button. And when the submit button is clicked, I'm just going to show it to you right now. When the submit button is clicked, the URL changes to localhost 8080/phone/bill/calls. This is a different URL, and when this URL is processed by the web application, it returns dictionary on server contains 0 words. As I mentioned in class on Friday, when the Project 4 application, the Project 4 Maven project, out of the box, contains a simple toy dictionary application that gives you all of the parts that you need for your assignment and allows you to demonstrate that yes, everything works. So you can run the application, you can run the client, or at least now that I fixed it, you can run the client. You can you have unit tests and integration tests. You have all the stuff that you need, and you of course have a working Maven project. You have all the stuff that you need to build your application. It just doesn't do what it's supposed to yet. It just does the simple dictionary. So back to my architectural grid diagram. When you load the index.html in the web browser, you get a form, and when you click submit on the form, it then makes an HTTP request to the URL host 1. So in this case, it's localhost is what we had. It's the phone bill/calls, and that all goes to the phone bill application. The wind just came up. Hope it doesn't mess up with the microphone. Sorry if it does. And so let's see what happens when that. Oh, okay. Sorry, and that is then delivered to port 8080, on which the Jetty container, the Jetty is listening, and then Jetty gets the URL, looks at the first part of the URL, the first file in the URL, which is phone bill. And then it routes it to the phone bill web application, which then says, aha, after the phone bill is /calls, and that's been configured to go to the servlet. So we went over this in class, but I want to touch on it again. We're going to use the Java debugger to work with the servlet to see what happens. Okay. So what we did before. Actually, I'm just going to go back to edit configurations here. So IntelliJ has these various configurations that it can run, run applications in, run Java stuff in. And so then, as you can see, it's got, oh gosh, all sorts of stuff. It's got some Android stuff. It's got Protractor, all sorts of neat things. But what we want to be able to do is attach to the Jetty process, or attach to the web container. So the web container, it's a JVM, it'll be running. We want to run that in debug mode so that a debugger like IntelliJ can attach to it. And all that and so what you do is you create one of these remote configurations. As a matter of fact, I'll just delete this and start over again so we can all see it. Okay, we're going to create a new remote configuration, meaning this is a remote JVM that we are debugging. I'm going to call it localhost 5005, because what we're doing is attaching to the JVM that's running on localhost on port 005. You can also attach to remote VMs that are on any machine that you can connect to. So there have been times where I've had to debug something that's running on one of the CS servers, and I'm able to attach to it remotely because everything happens over a socket. This is a debugging socket. This isn't the same as the web socket. That's on port 8080. And let's see here. I think everything else is pretty much the same. Yep, attached to a remote VM, the host and port. 505, 5005 is just what's the default. Now, what's really important here is this command line arguments for remote JVM. So when you run a JVM, the way you tell it that you are that you want to run in debug mode is that you set this big old, or you give it this big old command line option, this dash agent lib, and then all of this stuff. And I'll explain more of what this means a little bit later. But for right now, the most important thing is that to know is that you want this there on your command line. So I'm going to copy it to my clipboard. And now, when I run my Jetty, I want my Jetty's the Java command line that, or the JVM invocation that runs my Jetty to have that command line on it. And so the way you do that, since I'm running it through Maven, is that you set something. You set an environment variable called Maven ops. Okay. And then there, this is an environment variable that the Maven script uses to to build the command line for the JVM that's run. So now, when I go and I run my Jetty again, we'll see the first thing it does is that it says listening for transport DT socket at address 5005. So this means that the Jetty is waiting for waiting for a debugger to attach to it. And so now here in IntelliJ, I'm going to save this configuration. And now when I run that configuration, I run the debugger, and IntelliJ is saying, great, I've attached to the VM that's running on localhost 5005 using a socket communication protocol. That's super cool. Okay. And now I'm running my Jetty. Everything seems to be running. I will go back in my browser to this thing. Now I want to take a look at my phone bill servlet. We saw this last time. There is a lot of code here, but there are two entry methods. There's a do get and a do post. Now, these do methods correspond to the HTTP verbs, the verbs that are supported by the HTTP protocol. And so back to my diagram, when you make a GET request, the request is delivered to port 8080. The web container will look at phone bill, will route it off to the web application, and the web application, I guess I'll show it to you real quick. It's there in the web XML. When it's got a URL that is /calls, it routes it to the phone bill servlet. So here we are in the phone bill servlet. So I already have a breakpoint here in my get method. I probably also have one in post. Yeah. So now, when I guess one more thing. Just want to note that this first form here, the method, the HTTP verb that's used is get. And so it's saying, hey, when submit is called, or when submit is clicked, do make a get request of the call's URL. So now when I actually do that, I click submit, and IntelliJ pops up saying, hey, you're running in the debugger, and one of your breakpoints was just hit. So here we are in the doGet method. So when the browser makes a request, actually when anything makes a request, a GET request of the call's URL, it gets delivered here. And we saw a bunch of this in class, so I'm not going to debug through everything again, but I wanted to show you again how you do that. So now you can see that the first thing we do is set the content type of the response. Sorry, I guess there's one thing I want to reemphasize here. The doGet method, this is overridden from the HTTP servlet. HTTP servlet is a standard class, comes from the Servlet API. This class overrides the phone bill servlet, overrides the doGet method to process a GET request. And the doGet method is provided two objects. One is an object that represents the request from the client, and the other one is a response that represents the response that's sent back to the client, the HTTP servlet response sent back to the client. Bad things can happen. Not bad things. Things can happen during the method, and so then this method declares that it can throw either a servlet exception, which is a standard class, or an IO exception, our old friend that we've been learning about for quite a while now. So the request has all sorts of information, and you can use the debugger here to find out all about it in terms of the URL, et cetera, et cetera. What else is interesting? Well, if there were cookies, cookies would be available. All sorts of stuff. And of course, here in the debugger, you can let's see here. Oops, come on. You can say evaluate expression, and so you can say request dot. It's got all sorts of good stuff. So here, you can get the method. It's going to be a get. You can get parameter map. There were no parameters passed in, but we'll see in a little bit how all of that works. And so now there was no. Let's see here. Word is null, meaning that the word parameter was not set. And so then we're going to write all the dictionary entries off to the response. And now we're done here. We're going to continue. Sorry, I was using the buttons to navigate. I was using the keys to navigate. I'll use the buttons next time. And now that so basically what we've done is we've returned from this method. The JVM is off on its merry way, and this information has been returned to the client. So that's how a URL is processed. The URL request is made from some client. The server receives it. Ultimately, the request is delivered to your servlet. And it's up to your servlet to implement the appropriate logic. Here, what it does is, great, you haven't asked for the definition of any word. I'm going to give you all of the words. Let's see here. Next thing we're going to do is we're going to do something a little different. Let's go back to the index. Now we're working with the second form. This form, again, does a get call on the calls URL. Sends a get request to the calls URL. But now the form has an input, which is of type text, and the name of it is word. This translates into a URL parameter named word. And so then here, when submit is invoked, submit is clicked, do get is called again. But now, if I go and let's see here, is this inspect? Yeah, evaluate the expression, and I say request.get parameter map. It has one. It has one entry in it. The parameter word is mapped to the value doe, which is exactly what I put in here. And actually, then, if we look at the get request URI, what was passed in, and maybe I'll just do the URL, do the whole thing. What the heck? The whole URL that was sent to the servlet is http localhost 8080/phone bill/calls. So that's the URL that comes in. It's a get verb, and so it is routed to this doGet method. And now I'll implement the logic. And so now word is doe, and it'll go write the definition. We'll see that there isn't a value for it because I haven't put anything in there. And so, oops, I did not do the next. Sorry. I want step over. And now I want continue. Just let it do its thing. And then what was returned was a 404, because that's true. There is no data for the word doe. Next thing I want to look at is this third form. The third form's a little different. In the third form, yes, the action is the same. You're invoking the calls URL. But now we're doing it with a post. So a post is a different verb that's used in HTTP, and it's got two text fields. The first is called word, just like the one above it, and now the second one is called definition. And both of these will be sent as parameters to the HTTP post. So now when I say do, dear female, dear, when I submit this, my do post method on my servlet is invoked. And let's inspect the request again. Request, let's get the URL. Oops. It's the same URL, mind you, right? It's phone bill calls. But if I say get method, okay, it's a post. And now when I say get parameter map, it's got two parameters. It's got the word, which is mapped to doe, and it's got a definition, which is mapped to a deer, a female deer. Oops. Okay, so now let's step through this. We get word, which is doe. We get definition, which is a deer, a female deer. We're going to put that into our dictionary. So a dictionary here in our servlet is simply a map of strings, of string to string, which is the dictionary, right? This is the data structure for our application. And now what we're going to do is we're going to write some information about the word that was just defined. So the way we do that is we get the print writer from the response. Remember, like I said in class on Wednesday, the way you get the data to send back to the requester is that you get a print writer, a standard Java I/O print writer, and then you interact with it just like you would any print writer. So we're going to print some stuff to it. And we're going to flush it, saying, hey, please send all your stuff back. And then we're going to set the status code for the HTTP response, saying, hey, everything is okay. This is a 200. Everything looks good. And now we'll continue on. Great. Find doe as a deer, female deer. And now, when we ask for our definition of doe again, we're back in the get method. The word is doe. Let's step in here. And now we, as part of this write definition method, that's when we get the definition from the dictionary. And notice that the dictionary contains one element, the thing that we just added to it. So this is important. Well, actually, no, this is important. I want to cover it now. So the dictionary here is persistent across calls, is persistent across HTTP requests, right? The servlet is just sitting here running inside the Jetty container. So the client can come and go, but all the data is still there in the server. And that's how your Project 4 is going to work. You're going to have you're going to have a bunch of phone bills that are stored in your servlet, and then you're going to access them via HTTP requests. Okay, and now we're just going to write out the definition again. And we're all done. And now when we've asked for the definition of doe, there it is. So we just saw how in the web browser you can use these HTML forms to interact with the servlet via the web container, right? All the web forms do is that they make HTTP requests back to the server, both GET requests and POST requests. And fundamentally, that's what your application does, right? You've got the servlet that responds to GET and POST requests, and then you've got some clients that make those GET and POST requests. Where all the interesting stuff happens is actually, here on the right side, implementing all of that logic, and then here on the left side, taking things like command line arguments or writing unit tests and making them happen. let's go back to the command line. Okay, so we saw on Wednesday, and we saw again today how to run the server. But now, let me make it a little smaller so we can read it better. But now let's invoke the command line tool. Now this wasn't working on Wednesday, and I apologize. It's another thing that threw me off. But I got it fixed this morning, and make sure to check out my Summer 2020 repository for the changes that you need to make to your pom.xml to get all this stuff working. So now when I say, and I guess one thing to point out is that there are multiple jar files here. Oh, actually, the jar file isn't named phonebill.jar anymore. It's named phonebill-client because there's also a war file that's created by this. So now we say java-jar, and then you say target phonebill-client.jar. Good. This thing takes the command line arguments. And this is a simple command line application that is a Java program that interacts with your web application. So here it needs some information. It needs the name of the web server. It's running on localhost. It needs its port 8080. Just the same way that in your web browser you put this information in the URL. And let's see here. When you give it that information, it'll just be like that first form post that just returns all of the definitions in the dictionary. So when you run it, oh look, my do-get got hit. Well, that's good. My breakpoint was caught, so it looks like things are working. I'm going to resume my program. And yep, sure enough, there it is, the contents of the dictionary. I'm going to stop the debugger so I can run this without it catching every time. And then I'm going to, let's see here, I'm going to ask the definition of dough. There it is. I'm going to ask for the definition of me. Oh, it looks like an exception was thrown. Got an HTTP status code of 404. Well, that's cool. And now I'm going to say a name I call, actually I need a comma there, a name I call myself. There it is. I created it, and now I get them all. Now, I didn't, I turned off the debugger because I didn't want to have to stop it every time after one of these, but all this command line program is doing is exactly the same thing the web browser was doing. It's it's requesting the URLs, and it's requesting the same URLs that the forum did. It is asking for phone bill calls to get all of them. It's phone bill calls with a given customer name. Actually, I guess I didn't really highlight that. I'm going to do that, not customer name. A given definition. Actually, I just had it there. So when I look up dough, here's the URL that returns that. As a matter of fact, now you can use any web client you want. So I think I have wget. I don't have wget? Oh, okay. Curl. And I probably need to put all that in quotes because it's got question marks and stuff. I don't know. There it is. So when I hit it with curl, I get the same thing. And here again, I hit that URL. And I call it. So each time it's hitting the web server, and the web server is just doing its thing. That's one of the I don't know, lessons that I want you to get out of this assignment is that it doesn't matter what the client is, as long as the client and the server follow the HTTP protocol, the same thing happens. Now, let's talk a little bit more about the structure of the command line program. The command line program is also a Java virtual machine. So, inside a Java virtual machine, you have your project 4 class. This has the main method. And your project 4 main method leverages an object called the phone bill REST client. This is some Java code that makes it easy to create the HTTP request, get all the parameters set correctly, make sure everything is properly encoded, and then go off and make that request. Then handle the response that comes back. and do things properly. This is basically a wrapper provides a nice Java API around calling this REST API. This is a very common pattern, and you can imagine why you want to do this, right? It provides a nice encapsulation of the REST client, and it makes it easier for the Project 4 to use it, because the Project 4, as we'll see in a moment, doesn't really have to deal with all of the internals of HTTP and forming the URLs and handling the responses and stuff. It just calls a bunch of Java methods. That's very convenient, both in terms of separation of duties, but then also if something changes about the underlying REST API, most likely you can change the REST client to handle those changes, and you don't need to then modify the code that uses the REST client. So let's see here. Let's go look at the Project 4 class. Here is Project 4. Project 4 has a main method. It does lots of parsing to find the 4 parameters, the host, port, word, and definition. That is not so interesting. Here is where it gets interesting. So here on line 59, I'm going to create my REST client. So this is a new phone bill REST client, and you give it a host and you give it a port. And then you interact with that client. So if there's no word is given, if one of the host and port was on the command line, then you print all the word definitions. And then what you do then is call this get all dictionaries entry on the REST client. The implementation of this get all dictionary entries method, which we'll see in a little bit, actually goes off and makes a REST call to get all this information and bring it back. That returns a dictionary of strings to strings, and then we format those dictionary entries off to, well, a string writer, which is then printed out as the message. If word is not null, then we go and we get the definition of the given word, and then we format that one entry. Otherwise, if both word and dictionary are provided, then we call this add dictionary entry with the word and the definition. That will post it to the server, and then we'll just mention that that's what was defined. If there are any I/O exceptions that are thrown while all this is happening, and you're doing I/O, you can imagine that an I/O exception might happen, then you print an error message in return. Otherwise, you print the message that was returned from the server, and you do a system.exit of 0. Now, I want to walk through this code with everybody, so I'm going to debug this code too. However, going back here, we've got 2 Java virtual machines. We've got our server here that actually it's running in debug mode too on port 5005. I also want to debug my command line program. So I'm going to do an IntelliJ. I'm going to create another debug configuration. Another remote. I'm going to choose a different port. This time it's going to be port 5006. And there's another option I'm going to set. I'm going to set suspend to yes. Now, hello, where is, I guess I can't edit this. Okay, fine. I'll set it on the command line here. So I'm going to copy this off to the clipboard. And now when I run my Java program, I'm going to put that whole thing on there. And actually now when I run this, it runs too fast for me to attach it to the debugger, attach with it to the debugger. So what I want to do is I want to set suspend to Y, which means that when the program starts up, it's going to wait for a debugger to attach before doing much of anything. So before the main method is invoked, before classes are loaded, it's like, okay, wait a second, I was told to wait for a debugger. So now I'm going to run the debugger, and it attaches to my, as it doesn't say, it attaches to my command line program, and it stopped here on line 59. So it parsed all the command lines, and now it's here using the REST client. I am also going to attach to my Tomcat. No, Tomcat. To my Jetty, sorry. So, as you can see in IntelliJ, you now have 2 debugging sessions. Because you are attached to, and you're looking at 2 JVMs. One that runs your Jetty, and the other one that's running your command line program. So now, let's step through the code and see what it does. So, first thing we're going to, and sorry, I'll start with here, and then I will switch over to keys, because it's way faster. So the first thing I'm going to do is I'm going to create my client. And now the logic says, okay, well, if word equals null, and it does, here's what I'm going to do. I'm going to call this get all dictionary entries method in the client. So I'm going to step into that one. And then here's the phone bill REST client, and here's what the get all dictionaries method does. It invokes this get method, which is actually inherited from its parent class, which is the HTTP helper. I'm going to walk through that shortly. So let's see here. And then it's going to get this response object, which is something that is returned by that HTTP helper, request helper. This is all code that I wrote for your benefit. And then it's going to call this Parse Dictionary. Now, what your code is going to do is it's going to return the phone bill, or the results of the query of the phone bill, in the text file format, and then you can just use your text parser here to turn it into a phone bill object. Okay, so I'm going to step into this. I'm going to step in again using F7. Okay, now I'm going to start using the keys. So the first thing that we do is, let's take a look at what is passed in here. So the URL string is, okay, the URL's right there. And let's see here, the parameters, there are no parameters, because that's right, we're just requesting the calls URL. So there's something we need to add to our query. Now we're going to create our URL. Now we're going to use, now URL here is a standard Java net URL. You learned about this in the lecture. And now we're going to do all the heavy lifting of using this URL API to make a GET request. So we're going to open up the connection. We're going to say, yeah, I'm doing a GET. Yes, please, do input and output. I'm going to create this new response object with the connection. I'll jump into there. We are initializing the object. And now we're going to go make the we're going to go make the request. So we're going to say, hey, get me the response code, which goes off and makes the request. It makes the request to the server, and oh, look, now the debugger, and we are actually in the debugger session for Jetty. Actually, can I rename these? Resize. I cannot rename these, so maybe I should call it Jetty or versus the command line. But anyway, now the debugger stops in the other debugging session. And saying, hey, the do get method was invoked, and that's very true. So this is one of the things that makes Project 4 interesting and difficult. You are dealing with multiple programs, code running all at the same time. I don't know how much concurrent programming you've done so far in your careers, but it is an order of magnitude more complex, because now you need to be thinking of multiple processes and threads, and what code is executing, and what state is the date in. All of this stuff comes together in concurrent programming. But it's also the way programming works, right? Gone are the days where you just have one application and it's, running your payroll calculations and stuff. You're dealing with all sorts of distributed systems now, whether it's a web application or whether it's a decomposed series of microservices that are communicating via messaging or using cloud technologies and all that kind of stuff. Concurrent programming is concurrent programming is a way of life. It's what we need to do now. So anyway, we're doing a GET request, and hey, let's take a look at the request again. It's that same URL we've been seeing, and it comes in with no parameters. That's exactly what we sent it from the client, and now let's just walk through this. There is no word, so it's going to write all of the entries. Okay, and I am going to then continue here. And if I go back to my other session, now it's back here. The GET response code has returned, so the URL request has been made and it's returned. And it's set this.code. This .code is 200, which is correct. That was the return code that we set when everything goes okay. Now what we're going to do is we're going to read the contents from the HTTP response. So the servlet wrote the key value pairs, the dictionary entries, into the servlet response, and now we're going to read it from the connection. So we're going to get an input stream from the connection, and we're going to read over it one line at a time. So that line is dictionary on server contains 2 words. We're just going to append it all to this content string builder. I'll go through all of that. Oops. And now content is, yep, dictionary contains 2 words, me, a name I call myself, and doe, a deer, a female deer. We're going to set that, we're here in this response object, we're going to set that to the response, to the content. And now we're back in, that was all done in the get method. All that magic happened there, and now we've got the response. Let's take a look at our response. Our response object has a code of 200. It has content that was returned from the server, and it has the number of lines. I don't remember why I have that, but it was necessary. Now we're done with the get all dictionary entries method. Oh, sorry. I guess one more thing I skipped over there. This parse dictionary takes the content that was returned and parses it to create a map. This is meant to simulate your text parser parsing your phone bill. And now we're going to print a bunch of stuff out to the message, which is ultimately printed to system.out. Look, there it is. This is exactly what was returned from the server. And we're going to continue on. Actually, what we do is we're done then. And the JVM exited, and then as we can see, nothing's available because the JVM, I said process terminated, yes, because the JVM is done. Okay, so that's how the command line program works. The command line program has a main method, and then it relies on this phone bill REST client to do a lot of the heavy lifting. The assignment is to take this starting point, take this toy application, and turn it into, well, the Project 4. So Project 4, instead of managing a dictionary, it manages multiple phone bills. And instead of adding simple key value pairs, it adds phone calls to a phone bill. And instead of just getting the definition for a given word, you now query your phone bill to return calls that meet the search criteria. So that's ultimately what you need to do. There's one other way of interacting with the server that I want to show you, and that is the integration tests. So you know me, I'm a big fan of automated testing, and we'll get back to how to unit test this stuff in a little bit, but I want to show you integration testing. So, so far our integration testing has just been the command line stuff. And remember when we first saw like Project 1 IT, and I explained to you, it's like, well, listen, the reason this is different from a unit test is because your main method does different things. It does things like writes to standard output, and it does things like call system.exit. And if you do that kind of stuff in a unit test, you won't be able to capture it. You won't be able to work with it. Instead, I wrote that fancy framework that does allow you to capture what was written to standard out, and does allow you to capture the exit code, etc., etc. That's kind of a unique use case for integration tests. What a more normal use case is something like the following, where you have it's an integration between 2 components. So one of the components is going to be a web application. And then you're going to have tests that interact with the web application. And in order to run these unit tests, then the first thing you need to do is start up your web application. Well, luckily, Maven, I've configured the Maven project to do all of this for you. It will launch Jetty, and then it will run your integration tests against that Jetty. And so if you run Maven Verify, yep, it'll do all of that stuff. But while you're developing your integration tests, you'll just want to have your application, running there in the background on the command line, and then your tests can interact with it. So let's see how all of that goes. So now if we look at project for IT, this is the integration test for project 4. Um, let's see here. And what it, well, actually, you know what? I'm going to look at something else first. I'm going to look at the phone bill, the REST client IT. So this is a test for the REST client. So the REST client interacts with a running server, and so then when we and so then when we test the REST client, you need to have a server running. And so the let's see here. So like here's the first um, here's the first method. Here's the first test method. And what I'm going to do is I'm going to run this test under the debugger. So this is IntelliJ. It's now running the tests. IntelliJ is a Java program, actually. And so now we've got yet another Java machine. Oh, I didn't like it. I need to rebuild it. Rebuild project. It's yet another Java virtual machine right here that now it's responsible for running these integration tests. And this is the same thing whether you're in IntelliJ or whether you're in Maven. It now runs the integration tests that make the same URL calls off to your Jetty, off to your web application. Yes. Okay, that's fine. Now when I debug this, it's much happier. The first thing it does is it creates one of these new film bill REST clients, which is, I'll step into it. It gets a hostname and port, which is all configurable. And then it calls this remove all dictionary entries. Oops. This is actually a method that's there for testing convenience. Let me go back to the servlet. It calls the delete. Do delete. So I'll set that here. Then I'll go back over here. So I will call delete on the URL. The URL, of course, being phone bill calls. And that's what delete does. I'm not going to walk through all of it, but it returns a response. Now the do delete is called on my servlet. That clears the dictionary. This is helpful for testing. This is not something you want in a real application, right? You don't want like delete all of my credit card information. That would be bad. So clears the dictionary and says so, and then prints and then returns OK. Okay, and if we go back to the test, then if we go back to the test, then I guess we need to continue from the debugger. Sorry. No. Oh, here's right. Console. Yep. Still running. Now, I guess that reran it again. So now if we continue, and now we're probably stopped over here again. Oops, debugger. Oh, what is that? Sorry, I'm a little lost right now. What's going on? Interesting. Come on, test. Where are you at? I'm gonna pause it. It is calling this, so it should be. We'll resume debugging, and so it should be stopped over here in the debugger. Let's resume debugging. Oh, there it is. Okay, cool. And now I just continued there, and now if we go over, we'll see that yes, it passed. And so then these are integration tests. They use that phone bill REST client API to do things. And as you evolve your phone bill REST client, I recommend that you write integration tests for it. And this way you know it'll work. You'll know it'll work when it's running inside Jetty. This one. Let's see here. I guess I don't have it here. One thing I wanted to point out. Somewhere in the HTTP request helper. Where is that? Maybe it's not here. Maybe it's in the client. I think it's in the client, actually. Sorry. Phone bill REST client. Oh, yeah, I'm looking right at it. Okay. If, what is this? The value is never used. Well, that's good to know. If your servlet does not return a 200, an HTTP OK, how should you relay that information back to the user of the phone bill REST client? The whole idea of the phone bill REST client is it provides a Java API, right? Something that uses Java things. So you've got, if we go back to what it's got like, add dictionary entry, and you give it the word and definition. Well, in Java, what happens when things go wrong? How should you convey that something has gone wrong? Well, you could have a return code, I suppose, but then your get definition method, you really want it to return the thing that was defined. So instead of returning some esoteric error value, instead you throw an exception. And so when this throw exception if not okay HTTP OK status is invoked after every request is made from the server to the server, and if a non 200 error response, non 200 status code comes back, then it throws what's called this phone bill REST exception. And so then the user of this code, phone bill project 4, which is over here. Project 4, well, really ought to catch, and apparently it is not. Yours should catch that phone bill. That phone bill REST exception, and handle it appropriately, right? Print out an error message. Okay. I guess one more thing I want to show you. I'm going to stop my server. I guess it was. Sorry, there was also. There's also the project 4 IT. This is just invoking your main method. So actually, this should look really familiar to you for projects 1, 2, and 3. This is kind of neat because it hides all of the details of working with the REST API. It's just invoking your command line application. This is where you can test your command line parsing, making sure that your port is a number, all that good stuff, and and go off and test it there. And the reason you have different integration tests for this is because you have different classes for it. The same separation of duties applies, right? You just want your integration test to focus in on interacting with the command line. You don't need to have it test anything other than the command line interface because you've got the phone bill REST client integration test to deal with like the next level down. So now, when you run your Maven clean verify for the project, what this does, first of all, it builds your application. So it compiles your servlet, it compiles your project 4, your phone bill client, all of that stuff. And it builds the client jar that we ran over here on the left, and it also builds the war file, which is ultimately deployed to Jetty. It runs the unit tests on the code, and then it runs the integration tests. Before the integration tests are run, it starts up a Jetty and deploys the web application to it, and then it runs the command line. Runs the integration tests against it. That's what it's doing right now, and then it stops the web server, and then it goes and checks to make sure that yes. Then it also does code coverage. Right, and so even with this one, you have code coverage. I don't know if that's merged or not. Oh, it does. Okay. Well, cool. So let's see here. So those are a number of the big pieces parts of the phone bill REST project. So again, you've got your web application running off in Jetty. Then you've got a variety of clients. You'll mainly be dealing with the Project 4 and the integration tests. I have the form there because for people that are familiar with HTML, it might be easier to deal with. If you're not, ignore it. It's not part of the assignment. You won't be turning it in, or if you do turn it in, I'm not going to run it. Actually, I think you do turn it in because there's that integration test for it. So don't need to, but you don't need to do anything with it unless it helps you do the assignment. Okay, so this is the architecture of the of Project 4. We talked about how Jetty runs this thing called a servlet that is the behavior of your REST API that handles requests and returns responses. And we saw three different clients. We saw how you can interact with this web application with your servlet through the web browser, through a command line tool in Project 4, and also the integration tests and how they all work with the server. They all make the same HTTP calls, same HTTP requests, and all get the same response. They all handle it differently, though. And we saw how you can test your servlet using the integration tests. And the integration tests are great because they interact with the servlet in the actual environment inside Jetty. And so you know it's going to work. If your integration tests, work, then it'll work the same. Then you know that functionality is available to your command line application and to your web browser. However, there's a downside to just developing with integration tests because there's a really long feedback cycle. If you think about the integration tests that we had with projects 1, 2, and 3, those were just invoking the main method, and the reason we had those integration those as integration test is because they were interacting with the command line that does things like writes to standard output and to standard error. It also call exit codes. We needed all of that framework in there. But for Project 4, the integration tests are more like what you traditionally think of integration tests as being. They start up the Jetty container and interact with it via the HTTP requests. But this means that if you're using test-driven development and you're writing your tests to fail, and then you need to implement the test to get to pass, you change your servlet code, and every time after you change your servlet code, you need to then stop your Jetty and rerun Maven Jetty run so that it'll recompile your servlet code, redeploy it to the servlet, start up your web application again. That takes quite a while, and you don't have that rapid feedback that you get with unit tests. So now we're going to talk about how you can unit test your servlet. We touched on this in class, and I want to go into a greater depth here. So now our servlet is a Java object. Yep, it extends HTTP servlet, so it has methods that can inherit like do get and everything. But at the end of the day, it's a Java object, and so we should be able to run it in a unit test, right? Well, it's kind of complicated because you have things like the do-get method, which is what you'd want to test inside a unit test. It takes this HTTP server request object and this HTTP server response object, and you go and look at these things, and well, actually, I'll just look at it this way. You look at your response, for instance, and dot. Sorry. You look at it, and it's got all of these methods that you have to implement. I mean, yes, it's an interface, I suppose, but I don't have to, create an object that implements all of that stuff. And the same thing with a response. So what I would love to be able to do is be able to to work with my do-get method and provide it with HTTP servlet request and response objects that do exactly what I need the test to do. And that's exactly what we've got inside our phone bill servlet test. So our phone bill servlet tests use use a library called Mockito. And you can learn about Mockito in the dependency injection lecture, I believe. And what it does is it uses a lot of magical features of the Java runtime, things like reflection dynamic proxies, to create objects that behave and actually are HTTP server requests and HTTP server responses. They create these mock implementations of them. That's what we do right here. We create a mock servlet request, a mock servlet response, and a mock print writer. The print writer we need because we know that our servlet interacts with the response's print writer. And so we want to be able to then provide our test, our code under test, our doGet method, with a print writer that can interact with. So we use this mock method to create the objects there. And then we need to do some configuration of those objects so they behave in the way that we expect. And so then we call this when method, which says, listen, when the getWriter method of this response object, of this mock response object, is invoked, then have that method return this mock print writer. And then we send this mock response and this mock request off to our doGet method. So let's, here's what I'll do. I will open this up in another tab here, because, like for instance, under test, our doGet method, it's going to call, it wants to be able to set the content type. It wants to be able to call this method on the response, and we'll see. Oops, where did that go? There you go. And we'll see in the debugger how all of this works. So let's run all of this under debugging. Remember, this is a unit test. So the servlet is not running in Jetty right now. It's running all in this unit test VM. So I create my servlet object, and then I create my mock object. It's got to load classes and do a lot of magic. That's why it's taking a moment. But what I get is this request object, and this request object implements the HTTP servlet request interface. But look at its type. It's like, okay, HTTP servlet request $Mockito mock, a whole big crazy thing. Okay. So it is a servlet request, but it is not probably the one that you would expect. And I create two more mock objects, one for my response and one for my print writer. So if I were to call response.getWriter right now, it returns null. Well, that's not what I want, because if I go to my write dictionary entry thing, and I call, and if the response that I send in returns null, I'll get a null pointer exception. That's not what I want. I want my code to be able to interact with that print writer. So that's why I need to call this over here in my test. I say when that method is getWriter is invoked, then return my mock print writer. So it calls that, and now when I do the same thing, when I call getWriter, it now returns this mock print writer thing. It's the same print writer down here. It's 2313, 2313. Okay, that's cool. Now I'm going to send those two mock objects off to my doGet method. And I'm going to start interacting with them. I'm going to set the content type. And now I'm going to call getParameter. And the first thing the getParameter does is it calls, well, getParameter with the word. I think that's what name is word, right? Oh yeah, word down here. And that returns null. That's the cool thing about Mockito, right? Even though it's like this mock object, it still says, well, okay, I'm going to return null, which is exactly what I want to do in this case. Because there shouldn't be any dictionary entries. I'm just getting all of them. And so then the word is null, and so now I'm going to write all the dictionary entries. And I'm going to get the print writer. That print writer is my mock print writer. And I'm going to call print line with, wow, this big old string right here. Let's see what that is. That is dictionary on server contains 0 words. Okay, I'm going to write that to my mock print writer. There are no entries, so it doesn't write anything else. I'm going to flush the print writer. I'm going to set the status code to OK, and I'm going to continue on. Oh, I'm back at my test because my doGet method is returned. Now I'm going to call verify. So what these mock objects do is they have all this magical bookkeeping that keeps track of what methods were invoked on them and any values that were passed into those methods. And then you can use that magical bookkeeping to verify that yes, the mock object was interacted with in the way that I expect. So I'm going to say, hey, verify that the printline method of the printWriter object was invoked with this value that I expect, which is, sure enough, dictionary on server contains 0 words, so that should pass. That is, yep, that's what's expected. And the same thing with the set status method. I'm going to say, hey, I expect that status code 200 was returned there, and it was. So again, what these mock objects allow you to do is unit test your code that expects to run in this kind of complex servlet environment, a complex web container environment. But you can unit test it outside of that environment, and this is really powerful. Because what it allows you to do then is get code coverage on your servlet. You make sure that the logic is correct. You can do test-driven development. You only need to write the code that is necessary to get the test to pass, and you can still write tests using the using the required API. So that is how you can test your doGet method. We'll continue on there and see that it passes. Yes, it passed. Good. I also want to walk through this other unit test, which is for the post method, which is actually adding something to the dictionary. So here it's a little different. Actually, I probably didn't want to look at the debug output. Here, we're once again going to create our servlet. This is the code under test. And now what we're going to do is we're basically going to say, hey, here's the word, here's the definition. I want to make sure that I can establish this definition in the dictionary. So I'm going to have the word in the definition. This is test stuff, test data. That's the word I was looking for. I'm going to create my mock request, and now I'm going to configure my mock to say, listen, this is I'm going to be mocking out a post of the word and the definition, and the way I'm going to do that, I'm going to say, hey, listen, hey mock request, when the word, when your getParameter method is invoked with the word argument, then return our test word. Similarly, because right now, before I call this, if I say, I wonder what I just did there. When I say request.getParameterMap, it's empty, and actually getParameter, let's just be clear here, word is null. But then after I execute that code and I run it again, now it's test word. What we're doing is we're configuring or teaching our mock objects how to behave. And remember, these are objects that are passed into the code. So this is not part of the code under test. This is part of the test itself. Okay, so I've mocked out my request, and I've configured it to behave the way I expect, the way it would behave when this comes in from a browser or from the command line or whatever, command line tool or whatever. Now I'm going to create my mock response. Now, in the first test, I set up a print writer and I validated that that this text was invoked on the other print writer's printline method. I want to do something a little different in this test. Instead of saying, hey, was this test invoked via printline? All I want to do is I want to capture all of the text that was written to the writer. I don't care if a printline method writes it. I don't care if a print method writes it, et cetera, et cetera. Just give me all of the text. So the way I do that is I create, first of all, a string writer. A string writer is a writer that wraps a string that buffers stuff up in memory, buffers text up in memory. And then I create a writer around that. And by the way, these are not mock objects. These are, honest to goodness, actual Java I/O print writers. So there's no mocking here. But what you can use is this real print writer, and you can say, hey, listen, when the writer is invoked, use this real print writer in there. So you're still configuring the mock object, but you're configuring it to return a real print writer. And this is good, because then that print writer wraps around the string writer, and we'll see later on how we can then get the text out of the string writer to then test against it. So I've configured my request and my response to behave the way I expect. I'm going to step in there. And now let's see here. Now we're going to call getParameter with Word. So now we're going to say request.getParameter, and that's going to return test word, because over here in our test, that's what we told the mock object to do. Hey, listen, when getParameter is called with word, then return the test word. Same thing with definition. Definition, return test definition. Now I'm going to put that into the dictionary. And now I'm going to write some stuff. I'm going to get my print writer. This print writer is an actual Java I/O print writer. Let's see here, 2759. If I go up on the stack, back to my test, I'll see the print writer there is also 2759. Actually, can I do that? Yes, there you go. And that's where I created it right there. I'll go down the stack here into our phone bill servlet. I'm going to write out the definition there. And by the way, let's see what that text is. I'm just going to evaluate that. That is define test word as test definition. Why are you yelling? I'm going to flush, and then I'm going to set the status code to OK. And done with my do post. So okay, I have now I have sent my mock objects into my do post. They have the do post method has interacted with those mock objects, and now it's time to interrogate the mock objects to see if they were interacted with in the way that I expected. So the first thing I'm going to do is I'm going to look at what was written to the print writer. I'm going to do that by looking at the string writer. So when I call string writer toString, this will return all of the text that was written to the print writer. Because when I call print line on the print writer, it then delegates off to the string writer and calls its print line also. And so if we look at stringwriter.toString, it says define test word as test definition, which is exactly what we wrote over there, and is exactly what we expect right here. Oops. Cool. Now, note for your assignment, you're not going to be, using this messages.defined words as. Instead, what you're going to be doing is using your text dumper to generate text. And maybe here you want to use your text parser to parse it back in. I don't know exactly how you want to write your unit tests, but that's what you'd want to do instead of using all this messages stuff. Good, that passed. In our first test, when we verified the response, we said, hey, make sure that set status was invoked with this one value. And that worked fine for this test, but there are some times when you want to, capture the value that was invoked, capture the interaction with a mocked method, and then do multiple sets of validation on it. And here's an example of how to do that. You use something called an argument captor from Mockito. And this says, hey, give me something that'll capture an integer. And it's kind of a wacky object, but you can do the following with these argument captors. You can say, hey, verify that the set status method of my response object, my mock response object, was invoked, and please capture the value it was invoked with into this argument captor. And then you can, so please go do that. And now you can ask the argument captor, hey, what was the value that was captured? And sure enough, it was 200. And so now you can use this captured value in a Hamcrest style assertion, which is a little easier to read than verify. And you could also put this in a variable and then interact with it in multiple ways. We're going to assert that it's equal to, SCOK, it was 200, and we're good to go there. The last thing I wanted to show you in this unit test is the following. So we have interacted with all the servlet code, but there could be a bug lurking in the program that even though all of the right stuff was, read from the request and printed back to the response, it's possible that the underlying data structure, the dictionary itself, wasn't updated. And so then what we have here is this get. I added this get definition method on the servlet, which is is package private. It's visible for testing, but it's really not meant to be invoked by anybody else. And basically, what this does is allows you to sort of sneak in behind the scenes, look at your data structures, like, hey, give me the definition for this word. And I want to make sure that it was actually assigned, that the underlying data structure was actually updated with the information that I set in there. So now we have that thing too. It all passes. And so then the unit tests run this way. So this quickly, and I'm sorry I went through it a little fast, but this discussion is long enough. This is how you can unit test your servlet. And this, again, gives you a lot of power because there's much rapid... You can do test-driven development with a unit test. You really can't feasibly do test-driven development with integration tests because it just takes so long to turn the crank, right? You add a test, you update your servlet, you think you have it working, then you have to restart your web container, restart your Jetty, then run your tests again. That's really slow. So what I recommend that you do is that you use that you put as much validation in your unit tests as you can, get great coverage that way, and then have your integration test focus in on the logic that's there inside the phone bill REST client or inside your project one. And again, that way you'll just get the code coverage on the on that client side code. You really won't be using it for server side code coverage. Okay. Anyway, that's plenty for today. We've covered a lot. My intent with this was to walk you through everything, maybe at a less rushed pace than I would have during class, worrying about, hey, will we have time for the mob program exercise or whatever. We will revisit this again in class on Wednesday. If you have any questions, please feel free please do reach out on the Project 4 channel on Slack. And I'll answer them as soon as I can. Please finish up Project 3 so you can start moving on to Project 4. It is a lot more complex than the other projects. Until I see you next, have a good rest of your weekend. Hope you can enjoy this gorgeous weather we're having, and I will see you on Wednesday.